What we're going to do in this video is talk about the difference between proportional equations and fractional equations. These were two different lessons that you learned in your equations unit. As we look at these examples that I have here at the top, I'm hoping that you're recognizing those as proportional equations. The reason why they're proportional equations is you have one fraction, it's a big fraction, but one fraction equals another fraction. Over here you have one fraction is equal to this binomial, but if I put this over 1, now I have a fraction equals a fraction. And in this event, you can just cross multiply. So I'm going to just cross multiply over here, and I'm going to don't forget to distribute. So you're going to do 2 times 2x plus 4 is equal to, now I happen to have 1 times 3x minus 1, so I can realize that that's just 3x minus 1. If it were any other number aside from 1, I would have to distribute like we do over here. So I'm going to distribute. I'm going to get 4x plus 4 is equal to 3x minus 1. I'm going to subtract my 3 from both sides and get x, and I'm going to subtract 4 from both sides to get negative 5. So now I know x is equal to negative 5. Okay, over here, same idea. Fraction equals a fraction. I want you to look at it and say, okay, this is not so bad. I'm just going to cross multiply. 1 times 5x plus 6 is just 5x plus 6. And then I'm going to do 4 times 3x minus 2. Don't forget to distribute. So it's 4 times 3x minus 2. Right? Then it creates one long linear equation once you cross multiply. Bring down your 5x plus 6 is equal to 12x minus 8. Subtract my 5x from both sides, get 7x. And I'm going to add 8 to both sides, so you have 14. Final step, divide by 7, x equals 2. All right, so those are your proportional equations. If you recognize your fraction equals a fraction, it's really nice and easy to just simply cross multiply. Okay, now as I scroll down, I want you to realize these are not proportional equations. I don't have just a fraction equals a fraction. You can't just cross multiply here. You have a fraction plus a fraction is equal to another fraction. You got a whole lot of fractions going on in here. So what we do is there was one of two methods, the method where you got your common denominator across the board or using your multiplier. The first one I'm going to show you is your common denominator method, all right, where we're going to get a denominator of 5, 3, and 15. A common denominator would be 15. So I'm going to change all of my denominators into 15. In order to take this first fraction, I would multiply by 3, so I'm going to multiply the top by 3. That's going to give me 6x. For this one, I'm going to multiply by 5, and then I'm going to multiply by 5, so this is going to give me 5 over 15, and this already has a 15 in the denominator, so you're just bringing down your 7x minus 2. Once all those denominators are the same, you get to cross them all out. We are only allowed to do this when we have an equal sign, an equation. And then 6x plus 5 needs to equal 7x minus 2. We just made it super easy. Minus 6x from both sides, you get x. Add 2 to both sides, you get 7. So now we have x is equal to 7. Okay? All right. Over here, same idea. Hopefully you're not seeing it as a proportional. I'm going to go up here again just to show you the difference. Remember, a proportional equation is when you have a fraction, one fraction equals another fraction. Okay, one fraction equals another fraction, or over here, one fraction equals another fraction, as opposed to this has a lot more going on. So you just want to recognize the difference between the two. You're going to use the common denominator method, which if you like using that common denominator method, I want you to go forward and use that common denominator method. Over here, I'm going to use the multiplier method, which is very similar. It gets you the same outcome, a little different. 5 and 2 have a common denominator of 10, and all you do for the multiplier method is you distribute the 10 and you simplify. 5 goes into 10 twice, so all of this simplifies down to 2m. Distribute the 10 to the next fraction. Here's my 10. 2 goes into 10 5 times. So now I have this 5 with this 3. So 5 times 3 is going to give me 15 to then multiply by m minus 1. And then I'm going to distribute the 10 over here. And I have 10 times 2. So this is going to equal 20 times m minus 3. If you use the common denominator method, you would end up with this exact same equation. And then you would be able to distribute. Don't forget to distribute over here. Combine my like terms. And then I would subtract 17 to get 3m. I would add 60 to get positive 45. Watch the signs, and then divide by 3. And m would equal 15. Okay, you can take this 15 and come back up here and plug it in for a check. It's possible. If you plugged it in, 15 divided by 5 is 3. 15 minus 1 is 14. 14 times 3 is what? 42, right? And 42 divided by 2 is going to be 21. So on the left side, I got 24. Let's see if I get it on the other side. 15 minus 3 is 12, and 2 times 12 is also 24. So just because it's this fractional equation, don't think that you can't take your value and plug it in. Some of them are easier to check than others, but sometimes it's worth it if you're feeling a little bit worried as to whether or not you made an error somewhere. You can re-plug it in and do a check. All right, so let's kind of summarize by looking at 2 more of these. One where you have your proportional equation and one where you have your fractional equation. And again, looking at the 2 of these, I hope you're saying, if I were to say to you, hey, which one should I just cross multiply? I'm hoping that you're looking over here. This is your fraction is equal to your fraction. So you can just cross multiply and get x minus 2. Don't forget to distribute. It's actually 3 times x minus 2 is equal to 2 times x plus 1. Excuse me, I don't know why I said that. 2 times x plus 2. And then you're distributing 3x minus 6 is equal to 2x plus 4. Subtract 2x, you get x. Add 6, you get 10. And again, just for good practice, I can check. I can take my 10. 10 minus 2 is 8. 8 divided by 2 is 4. Over here, 10 plus 2 is 12. 12 divided by 3 is 4 also. Remember, our ultimate goal with checks is for you to decide that you want to check and make sure you did a good job. This one is a very interesting one to talk about. Now that I look at it, I did incorporate a little subtraction in here. That's a big game changer as you're working your way through this. All right, so again, I'm going to use the common denominator method. I think it's the most popular. You could prove me wrong. Again, 4, 2x, and 4x all go very nicely into 4x. So the common denominator that I'm going to get is 4x, right? So I'm going to break my 4x's down, which means I'm going to multiply this guy by x, which means I get 3x on the top. I'm going to multiply this by 2. This by 2, so I'm going to get 2 over 4x, and this I don't have to change at all. So far, so good, right? Nice and easy. So now, since all your denominators are the same, all of this goes away. Don't forget about this little minus sign here. So now I have 3x is equal to 2 minus. Now, this minus is now connected to this 2, and I have this x plus 11. You want to realize you are actually distributing a negative 2 in here. Sometimes that's a subtle piece in there that goes unnoticed, and you just want to realize that it's there. So I'm going to now have a negative 2x and a negative 22. I'm going to then add my 2x to both sides and get 5x. I have 2 and negative 22, which is going to get me a negative 20 on the right-hand side. And when I divide by 5, I'm going to get x is equal to negative 4. All right, and let's see if I'm any good at what let's see how we got. If I did a check. I don't want to back away from the check. Sometimes they're ugly. This is not my favorite one to check, but I'm going to do it anyway, right? So on the right-hand side, I have 3/4 is equal to, so I'm up here. This is 1 over 2 times negative 4. There's my minus sign. 2 times negative 4 plus 11, all over 4 times negative 4. Right, so if I wanted to do this, and I'm doing it cold, no calculator, so this is equal to, this is going to be negative 1/8. I hope you see that, right, because this is going to give you a negative 8, same as negative 1/8. All right, I'm going to distribute, so I'm going to get minus, this is what, negative 8 plus 11, which is going to be a negative 3 over negative 16, right? Hope you agree. Except I lost my 2. Oh no, I'm sorry. I did distribute my 2, got my negative 8. This is supposed to be a negative 22, guys. That's where I goofed. Maybe, I hope you saw my goof. Right, so we got to be careful. So this is negative 22 and negative 8. So that is going to give me my negative 14. Or positive 14. This negative and negative is going to give me plus positive. To get these like terms, I'm going to do times 2 times 2. So now I have negative 2 over 16 plus 14 over 16, which is going to equal 12/16. And lo and behold, if I divide both of these by 4, it will simplify down to 3/4, which is what we needed it to do. All right. I don't recommend you doing this all the time. You got to make sure you're finishing your tests on time, but it is nice that you can check if you wanted to. And if you're taking your Regents, it's something that you will have extra time that you could take to do that. All right. Again, so just to quickly summarize, for this particular one, make note of that minus sign that did have to get distributed, a little bit sneaky. And then you just want to recognize the difference between your proportional equations and your fractional equations. Make sure you're not trying to cross multiply with these. You cannot. You can only cross multiply when you have a fraction equals a fraction. All right. Nice job, everyone.